CIS 3730, representing detailed data and business rules. Shuguang Hong, Ph.D. Computer Information Systems. Georgia State University. Learning objectives. Describe entity properties using key, single-valued, multi-valued, simple, composite and derived attributes. Express relationship properties using attributes. Model dependency relationships using weak entity types. Describe unary, binary, ternary, and n-ary relationships. Simplify models using supertype/subtype relationships. Continue conceptual DB design lifecycle. This lecture continues the discussion of conceptual ER modeling. Discussion roadmap. Starts with attribute modeling, followed by introducing the concept of weak relationships. Then, the association entity types. Finally, the ISA, or the supertype/subtype relationships. Entity type is described by its attributes. The meaning of, and the information about an entity type is described by its attributes. For example, a student has student ID, name, email, location, etc. An advisory meeting includes room hashtag, building, date, time, etc. An instructor has employee ID, name, email, etc. Simple or composite attributes. Simple or composite attributes are used to capture the data elements and business rules about data in the user requirements. For example, student name consists of first name, mid-name initial, and last name. It is a composite attribute, include first name, mid-name, and last name. Use parentheses to show the component attributes. Location is also a composite attribute which contains street hashtag, street name, city, state, zip code. An attribute has no component is then called simple attributes like student ID and email. Single-valued or multi-valued attributes. An attribute may contain a single value or multiple values. For example, a student may have multiple phone numbers. It is a multi-valued attribute, denoted by a pair of curved brackets. The student ID, name, email, and location are single-valued attributes. If the business rule stated that a student may have multiple addresses, how do you model it in the ER model? Think about it and share your answer to the class. Computed or derived attributes. Some attributes are computed from other attributes. We called such attributes as derived fields in SQL database queries. For example, GPA is a computed attribute from the grades as shown in the formula. A computed attribute is denoted by a pair of square brackets as shown in this ER model example. Entity type requires a primary key. Like the relational data model, ER model also requires that every entity type has a primary key field. The rules for the primary key are the same as that of the relational data model. The uniqueness rule. No two entities can have the same key value. The minimality rule. No part of the key can be dropped without destroying its uniqueness. Interact with ChatGPT to understand and explore examples of different attribute types. Example prompt. I am learning ER modeling in my college database class. Could you help me understand the concept of composite attributes and show me some examples? Thanks. In-class exercise, I. Identify the attribute types in instructor. Discuss. Main key value. Is the candidate key concept applicable? Is a composite attribute automatically disqualified to be the key? Present your answers to the class and submit to iCollege for class participation. Attributes are not entities. It is to remind you that attributes should not be modeled as entities because those two concepts are different. Entities, entity types, are concrete objects, either physical or conceptual objects. That is, entities are independent and can exist by their own. Attributes are information about entities. That is, an attribute is only a piece of information about an entity, and it would be meaningless with being attached to the entity it describes. Some of the examples below are entities, but some are attributes. You should evaluate each of them and determine which one is an entity and which one is an attribute. Can program and department exist independently of each other? Which scenarios for mutually independent? Which scenarios for a dependency between them? The answers should be dependent on the user requirements. If the user requirements do not offer the answer, you should ask the user about the business rules on the data elements. Capture the concept of existence dependencies. If the following two business rules are stated. A program does not exist without the department offering it. If a department is removed, all its programs must also be removed. Then, the program is dependent of the department entity to exist. That is, the relationship between the department entity and the program entity is not like other normal relationships. It is a dependency relationship in which program depends on department to exist. Thus, program is called a weak entity or child entity, while department is called a parent entity or identifying entity. Use a round corner box to represent the weak entity. And use a dotted line to represent the dependency relationship or identifying relationship. How to capture attributes about relationships. The relationship between student and class captured which students took which classes. But how to model the fact that students received grades from the classes they took? We seem to have three choices. Place the grade attribute in the student entity. The grade field in student can store all grades a student got, but it cannot tell which grade was from which class. Hence, it failed to capture the complete grade information. Place the grade attribute in the class entity. This choice is also problematic. The grade field can store all grades for each class, but it cannot tell which student received which grade. So, it captured only partial information about the grade. Associate the grade field with the relationship. As shown in the table, the grade is always tied to the student and the class. So, the relationship is the correct place for the grade attribute to capture the grade information completely. The grade attribute is usually called relationship attributes, i.e., attributes describing a relationship. But, in the crowsfoot ER model notation, relationship is only a line and has no place for fields. The solution is to convert the relationship into an association entity using the round box in the ER model. The cardinalities of the associate entity, enrollment, to both student and class must be one-to-one and mandatory. It is because a grade cannot exist by itself. A student receives a grade from each class and a class assigns a single grade to each student. The cardinalities from student to the associate entity enrollment is the original cardinalities to class. The cardinalities from class to enrollment is copied from the original cardinalities to student. If you have any doubts about the cardinalities, please rewind the video to see the original cardinalities before converting the relationship to associate entity. In summary, we introduced the concept of association entity to capture relationship attributes. Beyond binary relationships, course prerequisites relationship. So far, we have talked about only binary relationships. But other relationships are not binary relationships like the course prerequisites relationship. A course may not be a prerequisite for any other course, but a course may be a prerequisite for many other courses. For example, CIS 3260 Introduction to Program is a prerequisite for multiple CIS courses, but CIS 4970 Field Study is not a prerequisite for any other courses. A course has none or multiple prerequisites. For example, CIS 2010 has no any prerequisite course, but CIS 4970 Field Student has 4 prerequisites, CIS 3260, CIS 3001, CIS 3300, and CIS 3730. This kind of relationship is different from binary relationships in that the entity types associated with the relationship is the same entity type, course. That is, the relationship loops back to the same entity type. Such a relationship is called unary relationship. A ternary relationship example, the car sales relationship. Here is another example of a non-binary relationship. The car sales relationship is between 3 parties, the sales representative, the customer, and the car sold. It captures the business rules that A car sales rep may sell 0 or multiple cars to customers. A customer may buy 0 or multiple cars from sales reps. A car is either not be sold or sold to only one customer. We used the association entity notation introduced earlier to capture such a ternary relationship between sales customer, and car as shown in the ER model. Interact with ChatGPT to understand and explore examples of relationship cardinalities and participations. Example prompts. I am learning ER modeling in my college database class. Could you help me understand the concept of relationship cardinalities and participations? Could you also show me some examples of those concepts? Thanks. Thank you for the explanations and examples. Could you help me compare and contrast those two concepts? Interact with ChatGPT to understand and explore examples of unary and ternary relationships. Example prompts. I am learning ER modeling in my college database class. Could you help me understand the concept of unary relationships and show me some examples? Could you also show how to model the relationship in the crow's foot notation? Thanks. Thank you. Could you explain the concept of ternary relationships and show some examples in the crow's foot notation? Entities of similar kind have overlapped attributes. Now, let's consider a scenario of entity types of similar kind. For example, student and employee entities are humans, i.e., the same kind of entities. As shown in the ER model, they have several overlapped fields. Person ID, name, address, and phone numbers. Such modeling practices caused several problems. They are redundant modeling efforts, inconsistent modeling, and, consequently, maintenance problems. Those problems are like the data redundancy problems we should avoid as much as possible. The supertype/subtype (ISA) relationships can reduce redundant modeling. It is an object-oriented programming concept applied to ER modeling to reduce redundant modeling. It is a very useful technique that can help us manage complex ER models. The concept of supertype/subtype, or ISA, relationship is called superclass/subclass or parent/child class in object-oriented programming languages like Java or Python. This concept introduced several concepts. Supertype entity is a generalization of its subtype entities. That is, student and employee are person in the ER example. That is, the person entity is the generalization of student and employee entities. Thus, person contains attributes that are applicable to all its subtypes student and employee. Subtype entity inherits all attributes of its supertype entity. That is, subtype entities inherit all attributes of their supertype entities. The inheritance is called class inheritance in Java/Python. Arrows represent the inheritance relationships. It is only one of notations commonly used, but they all should have the same meaning. If you discover that you deal with multiple entity types of the same kind, you may consider to use the supertype/subtype relationships to help reduce redundant modeling, that is, redundant work. University DB example, version 2.0. This is the University database design example introduced in the last class. We studied those two user views and created an entity relationship model, or the version 1 ER model. The conceptual ER model version 2.0 expanded the version 1 to version 2 model by adding attributes to each entity based on data elements and business rules in the user requirements. You may want to reference to the University DB application example document to see the detailed discussions. Note that the entities advisor, student, and instructor have several common attributes because they are the same kind of entities. This ER model applied the supertype/subtype relationships to capture the common attributes of advisor, student, and instructor. As shown in this ER model, it is cleaner and has less redundant modeling. It is the conceptual ER model. As shown in the example, we need to verify that the conceptual ER model captured all user requirements correctly. Refer to the University Database app example for detailed discussions. Summary. A conceptual model must capture all data elements and business rules. A complete ER model should include Entity types and attributes. Relationships, cardinalities and attributes if applicable. Weak entity types and identifying relationships. Supertype/subtype relationships if applicable. Conceptual ER models have no foreign keys. Entity types and notations. Regular and weak entity types must have primary keys. Weak entity type must identify its owner entity type by dotted relationships. Association, relationship, entity types have no primary keys. For types of attributes. Simple and single-valued, simple and multivalued. Composite and single-valued, composite and multivalued. Crowsfoot ER modeling notations. The notations for optional participation with 0, 1, or many cardinalities. The notations for mandatory participation with the 0, 1, or many cardinalities with. The one-to-one relationship notations with optional or mandatory participation. The one-to-many relationship notations with optional or mandatory participation. The weak relationships notations with optional or mandatory participation. The many-to-many relationship notations with optional or mandatory participation. Comparing with Peterson's attribute notations. The Peterson's notations use a single-line circle for simple, single-valued attributes. An attribute tree to show composite attributes. A double-line circle to represent multi-valued attributes. A dotted line circle to represent computed attributes. That's the end of this video about detailed ER modeling. Thank you very much for watching it.